X equals 0 is also known as the y-axis. And x equals 9 minus y squared. Is that a function? No. It's a relation, right? How would you go about graphing that? When x is 0, what's y? Or negative 3. So you know the thing hits at 3 and negative 3. And when y is 0, what's x? 9. So I'm just going to not make this to scale, but you get the idea here. So this graph goes like that, correct? Basically like that. How'd I do? Did I do okay? It's not bad. And then it's bounded by the y-axis. So what region are you looking at? You're looking at that right there. Yay! And what are you rotating around? X equals negative 1. So let's make this a little smaller. Move it over a little bit. And the axis of rotation is x equals negative 1. So you draw, let's say negative 1 is, I don't know, right there. Does it matter if this is totally to scale? No. So what I'm going to do now is I'm going to take this, and what do you draw with this? What do you do? Yeah, you draw the rotation, right? Yeah, something like that. Oh, no, not something else. It's right there, right?
No, not bad.
Not bad. The sizing is a lot, but the idea is now you have to do this either with shells or with washers. Which one do you want to use? You want to use washers? Really? Okay, here's the thing. Shells. Okay, well, here we go. Which one do you want to try first? You decide. Washers? Okay, so if you draw this washer in, you're going to draw, let me draw one and then you can just decide. You draw it here and we draw this. There's your washer, right? Yeah, but you have to go from, is this going to be dx or dy? Okay, so I want to help you out here. If you do this with dy, what's the lowest y value? Okay, so if you do it to negative 3, okay, we can do it. Fine, oh, that's actually fine. You're right, you're absolutely right. I'm sorry, this is a lot easier than I thought it was going to be. So it's going to be pi, right, from negative 3 to 3 of the big radius squared in terms of y minus the little radius squared in terms of y. What's the little radius? Yeah, we know that r of y is 1. It doesn't change. And what's the big r of y? 9 minus y squared plus what? Plus, why is it plus 1? A little bit more. You need a little bit more, exactly. Perfect, very good, nice. So you have pi from negative 3 to 3 of, what do we got here? 10 minus y squared minus 1 squared and dy. Now here's the thing. Is that correct? Sure. Is that nicely integrable, Griffin?
Yeah.
Well, yeah. What do you have to do to that before you integrate? Multiply it out. It's a polynomial. Now, can you integrate polynomials by hand? Would this be something that's fair game on the non-calculator section? Absolutely. What could you do? Can someone tell me one thing you could do to make this computation easier? There's one thing you could notice about this shape. You could half it to make it 2 pi from what to what? 0 to 3 of this thing. Do you see why the upper half and the lower half are identical? Do you see that? The upper and lower halves are identical. So you can go from 0 to 3. That makes it easier, A, for two reasons. One, it's just smaller numbers, but also you're dealing with 0 instead of a negative 3. It's a little easier to evaluate, absolutely. You couldn't do that because this is above and below on something that's rotating, that's symmetric across the x-axis here. We couldn't do it when it was the inside and when you were doing the inner and outer. Like if this was up like this, you couldn't do the inside and outside because this is a lot bigger radius than this. The upper and lower halves are the exact same, just reflected. Exact same. They are the same shape, just flipped over. The other case was not. Yeah, what we had before, I'll draw it for you here. We had this right here rotated with this, like that, like there. So then we took a slice, and we thought maybe, can you take this right here, and it rotates to the outside, right? Now, could you just double it? You can't because this one rotates to here, right? The inner one, which is right here, where does that rotate? On a totally different track. You see that track? It's much smaller. This one, these two halves rotate around the exact same thing. So you can in this case. So if you're doing this by hand, that's a great observation. Just be careful because it doesn't always work when you do the half thing, right? Be very careful. So can you do that with your by hand? Yeah. If you did this with a calculator, kids, if this was a calculator problem, like on a free response, they would be looking for either this or this, and then equals the answer. On the if this was a free response calculator question, you don't get any points for the work. They will look for the elements of the proper integral, limits of integration, the integrand, and then the answer. That's what they're going to look for. You don't get any extra points for doing it out by hand. This one first. Really draw a picture. Okay, so y equals, so you don't have to think about the big picture yet, but y equals cosine x. Does that go through the origin? At 0, when x is 0, y is 1. So what does this look like? It goes down, then up, and down, right? Like this. That's cosine. Nice. Y equals 0. What is y equals 0 known as? The x-axis. And I don't know what just happened there. The x-axis. So we have this boundary right there. There's y equals 0. And then you have x equals what? 3 over 2? 3 pi over 2. Sorry. Yeah, I'll keep this going because we're going to need it to. When does cosine equal 0? Pi over 2. Exactly. So if this right here is y equals 0, what's the boundary? We're going from x equals 3 pi over 2, which is right here. No, it's not there. Where is it? Oh, so is it right here? Is that it? You sure?
Yeah.
You're positive? You're positive? Okay, I'm just checking. So x equals 3 pi over 2. And what are we going to?
5.
So I should go a little bit more, huh? Nice. I'm going to keep this color going here. Yay! So where's 5 pi over 2? The second one? After the first one. So we're talking about, is it this point right here?
No.
Or is it this point right here? Is it this one? You sure? 3 pi over 2. You guys are confusing me. I'm going to pause this. Okay, so what region are we looking at right here? We're looking about this right here. Everybody sees that? Are we okay with that now? We good? And what are you rotating it about? The y-axis. So I'm not going to shrink this, but it's going to go like this, right? It's going to go all the way around. Now I'm just giving you this picture. We don't need to do the entire thing. I mean, I could actually draw some cool like wireframes here. It's going to go up like this the entire way, right? You see what I mean? It's going to sweep that out. We're good? Okay, so first of all, what do you want to use? Washers or cylinders? Nah. Cylinders. Cylinders. Please do cylinders. Well, can we just do it the easy way first? So let's just finish it. It's going to be 2 pi dx or dy? Dx. The shell, look, each one of these is going to look like this. You see this? It's going to rotate all the way around. Each one of those is going to rotate all the way around. So it's dx, right? So what's the radius? Radius is nice and easy on this one. No. It's just x, the distance from the y-axis, because we're rotating around the y-axis. And what's the height of this thing going to be? Cosine x, right, dx. And what are you going from? 3 pi over 2, did you dy? To what? Yeah, you're done. That's it. Now here's the thing. Why don't they say do that out? By hand. Yeah, you have no way of doing that by hand. What could you, if you could add in one number in one place, what one number would you add in one place to make that integrable by hand?
Squared.
No zeros.
Cosine
Cosine of x squared, and all of a sudden, yay, I can do u sub, right? No, you understand? That one's totally different. That one right there is integrable, but not in AB calculus land. You can do it in BC, not in AB, okay? If you did that on your calculator, which you're going to do right now in 60 seconds, tell me what the 3 decimal answer would be. Okay, kids, what's your first step on this one? Draw a picture, okay? This right here, what is that? What type of shape is that? It is not a circle. It is not a circle, and don't worry, even though I'm disappointed right now, it's blunted by the fact that all the other calculus students thought it was a circle. It is not a circle. It's a this thing. What's it called?
No idea.
No idea. It's a this thing. I like that. At least you got to this. It would be a circle if it was plus y squared. There's a key difference. It's minus y squared. What can you always do if you want to actually graph something?
Plug in values.
Find what? Yeah, plot points. Plot some points. There are some great points. A is a constant here, right? What points do you try to usually go for? One's on the axes, right? So when y is 0, what happens? What's x equal to? Well, x squared would equal. So x would be what? Plus or minus a. Correct. Plus or minus a. So if you were to graph these two things right here, what do you end up with? You end up with plus or minus a. Now what happens if you try to find the y-intercepts? You know, what happens if you try? So you have negative a and a right here. So we know the function hits at those two places, right? What happens if you try to plug in 0 for x? You can, and you end up with negative y squared is equal to a squared. What's the problem with that? The negative is a problem. Negative y squared can never equal a squared except when a is 0, and this is not going to be a very fun thing if that's true. So if a is anything other than 0, this is not possible. Are we good with that so far? Right? So what does that mean? Does it cross the y-axis? Doesn't, right? So this is a hyperbola. It goes out. It looks like this. Yay. And what happens on the other side? Same thing. So now, though, you have to graph the other thing. X equals this right here. What kind of line is that? A and H are constants. What is x equal a constant? What is that? It's a vertical line. It's a vertical line. It's a vertical line at what value? A plus H. Where is A plus H in relation to A? How much further? You know exactly where it is. It's H further, right? So let's put it right here. And we'll call this distance H. So what is this vertical line right here? X equals A plus H. So now do we have our enclosed region? We sure do. Our enclosed region is now right here. Awesome. And what are we rotating it around? Yeah, luckily we already drew the reflection, right? It's actually already there. Now in this case, what do you want to integrate this with? Do you want to integrate this with shells or with washers? Let's definitely do washers on this one. You know, if you tried to do shells here, you'd be going from the red to the red here. And do you like touching the same function with the height? No, you really don't. You really don't, because you have to break it up. It's not going to be fun. If you do washers, though, look what happens. It's nice. It's right there and there. There it is. You see that right there? Nice. Cool. Is it dx or dy? dy. So let's just piece what we know. It's going to be pi big R squared in terms of y minus little r squared in terms of y. And it's going to be... I know! I'm writing this out first. I also have to bake a cake tomorrow. You know, that's all things that are happening next. Yeah? Not really. No, I'm just making stuff up. Okay, what's the lowest y value? How do we... I know, it's so tough. Kids, the lowest y value and the upper y value, what do we need to find?
A plus H equals...
Yeah, when a plus h equals what? Okay, so you want a plus h is equal to the function, which is what? So it's you plus a plus h into that. You want to find where they intersect, right? So kids, I'm just going to give you the help here. You take this, and where do you plug it in? Plug it in for x. Okay, I'm just going to give you that little bit. So you know that a plus h squared minus has to equal. So what do you have to isolate? Y. You know, a squared plus 2ah plus h squared minus y squared is equal to. First thing that happens that's really nice, what cancels? These are gone. And then what do you get? You end up with y squared is equal to 2ah plus h squared. Well, that's kind of happy, right? It's not bad. We're isolating y, though, so what does y equal? 2ah plus h squared. Do you agree with that? Okay, so first of all, does it kind of make sense that it's a plus or minus of a number? Yeah, what type of shape is that red thing right there? It's a sideways what? It's a sideways parabola, so is it going to be symmetric over the x-axis? Yeah, so do we expect it to be a plus or minus a number for the inner? Yeah, it makes sense, right? Let's just let's make this a little easier. Oh, half and double it. Can we do that? Is it just like this one right here? Yeah, look, it's the upper and lower. Are you rotating around the same thing? You have the same exact shape flipped over, rotated in the same space. So can we just, instead of going from negative of that to the positive, what can we do instead? Stay with the positive. And what do we put in the front? 2. So put a 2 right here and make it 0 to the square root of. Now here's the thing. Those are constants, and it looks ugly. I will reassure you we're on the right track. We're fine. It looks ugly. When you see something ugly like that, what do you hope happens along the way? Something cancels or it simplifies out, right? I will tell you it's not going to simplify to something truly nice like 7AH, right? But it's going to be nice. It's going to be nice. So now what do we need to find, though? What's the next thing we need to find? Big R of what? What's big R? No, think. What is big? It's just a plus h. Don't overthink it. It's static. The big radius is right here. Here's big radius. All the way from there to there. As you move up and down, as you move that disk up, that washer up, does the big radius change? No. What is that distance? You know that this distance right here is a. So what's the distance from the y-axis all the way out to the end? A plus h. It's a constant. It doesn't change. What does change?
Function.
The green thing, right? The little r? What's the little r equal to? What's r of y? Ah, be careful. Okay, here's the thing. We know that x squared minus y squared is equal to. We need the horizontal distance, which is x, in terms of y, right? So we need to isolate what here? What do we need to isolate right there? X. Isolate x because that gives us the horizontal distance in terms of y. I'm trying to do a y, but my arm's crossed. Sorry. So what does x equal? X squared equals y squared plus. Are we okay so far? So what does x equal?
Y plus A. Ha ha ha.
No, don't say y plus a. Don't make me sad. Really, don't make me sad. So what does x equal? Do you agree with that? X equals plus or minus that?
Yes.
Kind of makes sense that it's plus or minus because it's the original function. It's a hyperbola. It's symmetric over the y-axis, right? So in this case, we're only looking at the right-hand side. So we only want the positive one, right? So what is it going to be? The square root of what? Plus a squared. Are we okay with that? So now we need to plug it in and actually do this integral. Wait. 2 pi. No, why do you have to subtract anything from it? You're going from the y-axis, right? Stop, right. I'm answering your first question. Here's your little, there it is, right there.
No, I see that, but can't you just do a plus h minus the function?
No, because the function, what we just got is this distance. We just isolated x, which is the distance we want. It isn't. You don't need to overthink it. That is the horizontal distance. We don't have to add or subtract anything from it, because what are we rotating around? The y-axis. Remember before we were rotating around x equals -1? So what did we have to add? We had to add 1 to it. Remember that we did before? So we don't have to add or subtract anything. So now it still looks pretty bad, but it's not as bad as it could be, and we're okay. 0 to what? 2ah plus of, and what? H squared. That's important, right? H squared. And what do we have for big R? So we have a plus h squared plus, oh, it's minus, thank you, minus the square root of y squared plus a squared squared, and it's dx or dy. Ah, all we have are constants in y. Are we okay so far?
Yes.
Yeah, we're okay so far. Well, some very nice stuff happens quickly. You have 2 pi from 0 to, we'll just call this q for now. And what happens? A squared plus h squared minus y squared minus. Are we okay so far? What's the nice thing that happens? This goes away, right? Do you agree with that? So what do you have right here? We have 2 pi from 0 to q of 2ah plus minus y squared dy. 2ah plus h squared, that's a constant, right? That's a constant, right?
Yeah.
And I think you already noticed there's a nice thing. Have we already seen 2ah plus h squared? Is it a good sign when you see commonalities like that?
Yeah.
That's either a really, really good sign or a really, really bad sign. That it's like wishful math. You ever seen those questions? I mean, you've done them before where it says, verify that this is the answer. So you know what the answer should be. So you're just, the important stuff is showing the steps. But people tend to get sloppy because they know where they're going. So what do? They start skipping steps or crossing stuff out when they're not showing their work. That's really good. We need to integrate, though. 2ah plus h squared is a constant, so we can integrate it pretty nicely. It's going to be 2 pi. It's going to be 2ah plus h squared times what? Y minus 1/3 what? Y cubed from 0 to what? Q. Remember, q is equal to the square root of 2ah plus, and I'm going to call that 2ah plus h squared to the what power? 1/2. Need to be careful here. Let's plug this in and see what happens. Remember that this is to the first power. I'm just giving you that so we can iron out an issue right here. So what does it equal? 2 pi times, we have to plug in this first, right here. And then we're plugging in 0, right? So what do we have here? 2ah plus h squared to the what power? 3/2. Sorry. Minus 1/3 times, oh, what is, we were plugging it in. Oh, it's 1/3, what is it? 2ah plus h squared to the what power? 3/2, right? Because you're cubing half. Oh, is that kind of cool? Right? So we have this, but then we're subtracting. What are we plugging in now? 0. 0. It all cancels out to 0, right? You plug in 0 in both of these places, and what happens? They go to 0, and you're happy. So what does this turn into? Well, we have one of these things and 1/3 of them. So what do we end up with? 2 pi times how many of them do we have? 2/3 times 2ah plus h squared to the. So the answer that you would see would be 4/3 pi times. Apples and apples here. Look, we have one of them and negative 1/3 of them. So how many do I have? 2/3. It's the same thing. Look, isn't that really cool?
I thought you were going to factor it out.
Nah, I'm not going to factor. I'm just going to look. One apple, take away 1/3 of an apple. I got 2/3 of an apple left. So yeah, there's your answer right there. That is about as streamlined as it gets. And that looks, if you just started at the end and I said your answer is going to be this, you might think to yourself without seeing the question, ooh, that's ugly, that's not very cool. But judging by how awful it could be, could this have exploded on you? You have to have a little faith. You're going out on a limb here. This is not traditionally a good sign. Do you traditionally want to put a limit of integration being the square root of 2ah plus h squared? You should get a little uneasy, but the first good sign, what was the first good sign that everything was going to be okay? This. That made you feel really, really happy. That made you feel really happy because you already had that as part of your, like part of your integral, part of your process. And then the second thing that made you happy was when you just saw this. You ended up with the same thing to the 3 halves power. You have the same base to the same power. That's awesome. So overall, yes, in the grand scheme of things, this final answer looks a little icky, but as you proceed in more math and do more general cases, it's going to be hard. It's going to get worse. Take a look at what we started with. This is super general. A could be anything and H could be anything. We just found the general definite integral for this. That's pretty cool. We press enter. Oh, there it is. Okay, so what I'm going to do now is I'm going to clear this, and I'm going to do x, which is the x value of the intersection right now, but I'm going to store it as a. And just so I have it, I'm going to do the y value, which is alpha 1, and I'm going to store it as b, just so I have the y value in case I need it later. Okay, so now what I'm going to do, math, not a good estimate. What are you integrating from and to? 0 to, literally you can put a right there. It's going to look a little different on yours. And now the function is going to be the first function, y1, minus the y2, because I typed it in as the second function. And it's going to be dx. Press enter. There it is, right there.
Wow.
Nice. Nice,
I mean,
right
you don't
there.
you don't get as specific of an answer, but to the 3 decimal places.
So the proper answer, if this was an AP question, kids, they would accept either 0.121 or 0.122. Either one would be fine. That's the those are the point of, that would be the area, and then the points of intersection, you'd have to go and put those in. So this was B right here. Nice. So when you rotate this shape around the x-axis, you have an upper curve and a lower curve, right? You have your upper curve and you're rotating it down around the x-axis. What are you going to use, washers or shells? Please use washers, right? There's your washer right there. It's going to intersect with it down there. So we have our upper function and our lower, and what are we rotating across? The x-axis. Yes, it's a rotational solid, so you're rotating around the x-axis right there.
Oh,
This is for C, yeah. So what's the integral going to be? Pi from 0 to a, right? Of big R, which is going to be y1 squared minus y2 squared dx. So if I go back right here, I do what, pi? Correct? I do math 9. It's going to look, remember, it's going to be the function int on yours. Math 9, 0 to what? 0 to a of y1 squared minus y2 squared dx. I press enter.
Is there any problem?
There it is. Hold on. Let's just finish this. You got to stop doing that and just let us finish the current one, and then you can go on to the next one. Hold on. So, if you did it, anybody verify that? Did you get that right there? You got that? So what would be the only proper answer for this one? 0.544. So let's finish D, and then we can go back and try alternate methods. That's this right here. That's why you subtracted out y2. That's why you literally did two things. You rotated the upper function around, and then you rotated the little one, and this is the space below. That's why it's subtracted. You see the subtraction right there? That's why it takes care of it. So what would this be? So now we have, kids, now it says rotated around the what axis? So you have an upper function and a lower function, and you're rotating it this way. So what are you going to use? You're going to use washers, right? So you're taking this and rotating it like that. Shell, I mean, I'm sorry. Sorry, there's your axis of...
Oh, okay.
No, you can. You could, but you're going to have to isolate the equation. It's not going to be cool. You have to put it in terms of y. Let's not, and just set it up easily. If we have our calculator, you can do it the hard way with the calculator or the easy way with the calculator. Which one do you want to do? Easy way. So in this case, the height of x, what's the h of x going to be? y1 minus y2. And what's our radius going to be? We're rotating again around the y-axis, right? What's the distance to the y-axis? No. No, the x. X. You know this. So it's going to be 2 pi, the integral from, and remember, we're dx, so it's going from 0. Oh, it should go through there, sorry. There's your axis of rotation right there. Goes through the y-axis. So it goes 0 to what? 0 to a, correct? And it's going to be x, right? Because that's the radius. But what's the height of this function? y1 minus, that's the height. So if you just stored that one x value, you can do the entire thing out now. It's going to be 2 pi math 9 0 to a of x times what? The height, yep. So I'll put in parentheses, yeah, if I could just somehow get off that. There we go. So y1 minus y2, close parentheses. Got to put the x right there. Boom. There it is. There it is. So this right here would be this is how I would have done it right here. This is the most streamlined way. Are there other ways to make it, are there other ways to do this? Absolutely. Could you theoretically, this one right here, could you use washers on this one? Yeah, sure, you absolutely could. If you wanted to do a washer on this is why it becomes really, really hard, everybody. Here's your slice, right? It's going to look like this. Do you see that slice? Is that dx or dy? That's dy, right? So if you want to use dy, what do you have to isolate? No. Yeah, so let's look at this one for a second. Let's look at this equation. Y equals x to the 6th minus x plus 1. Isolate x for me, kids. No. No, I will not. Please don't.